Here says to prove the area formula given above, assume that the included angle C is acute. Use the diagram alongside to prove that the formula is also true in the case where C is obtuse. So to prove it, first of all, I will write the area formula that the question gave us. The area formula says for non-right angle triangle, I always have B times A, 2 base. They have 2 base, B times A, the product of 2 base, times sine of the angle between them, which is C here. So it's the formula. Now I will go for the common formula that I always use for triangle, which says 1/2 the base A times height, which is here. Now I try to use the sine formula, which says for sine formula, I have, for example, I have angles here, which is, we know here it's a straight line. For a straight line, the angle is 180. So if it's C, it would be 180 minus C. So this angle would be 180 minus C. So I have the sine 180 minus C equals the opposite side of this angle over hypotenuse, which is here B. So if I want to make H as my object and write formula again, so H would be B times sine of 180 minus C. I try to use the supplementary rule that says, if we remember, let me recall the unit circle that says if I have theta here as my angle and I reflect this angle across this point across the y-axis, which is here, and we know the y doesn't change. We see, for example, we have x and y here. That was cosine and sine here. When I reflect it across the y-axis, I will have negative x and y. That means y doesn't change, which is negative cosine and sine. So I say I use complementary rule that says 180 minus theta. The cosine will become negative cosine and sine doesn't change. So I use supplementary rule. So here my sine doesn't change, which is sine of C. I say I use supplementary rule, that says sine of 180 minus theta equals sine of theta. Okay, now I write the h again here, h, so h equals B sine of C. It's step 3. Now I substitute substitute step C step 3 in this formula. So I will have A equals 1/2 of A times, instead of H I put this expression that equals H, B sine C, B sine C. We saw this angle was obtuse angle. So this angle was obtuse angle. So I could prove I can put C, which is obtuse as well. So doesn't matter it's acute or obtuse angle. I get the same answer.